Before we go to we talk about 12 leads ECG, it's very important to go back to our anatomy and understand the electrical conduction system of the heart, because 12 leads ECG is what we are going to monitor. There is the electrical conductivity of the heart. Okay, so if you go back, we will be talking about SA node, internodal pathways, interventricular node, bundle of His, left bundle branch, right bundle branch, Purkinje system. There are things that very important that we have to remember about this electrical conduction system of the heart. Okay, so first we talk about the SA node. SA node is actually what we call the major pacemaker of the heart, or the dominant pacemaker of the heart, which is located in the right upper part of your uh, portion of your atrium, right atrium, and it has intrinsic rate of 60 to 100 beats per minute. If you notice, this is actually the heart rate, our normal heart rate. That is why the SA node is the one dictating the heart rate. Okay, so that's why this is called the dominant pacemaker of the heart. Just remember, SA node is the dominant pacemaker of the heart with intrinsic rate of 60 to 100 beats per minute. So after that, the current will go to the internodal pathways. Okay, so the conduction will go to the internodal pathways. Now, actually, the internodal pathways is still located in the atrium, at the body of the atrium, the right and the left. Okay, so direct electrical impulses between SA node and AV nodes. Okay, so there will be a direct impulses connected to SA and AV node. So this internodal pathways is the connection between the SA node and the AV node. So after the SA node gives a 60 to 100 beats per minute, it goes directly to the AV node by the internodal pathways. Now remember the AV node, okay, which is located between the atrium and ventricle, okay, or the AV junction tissue, slows. This is important here. Slows conduct, conduction, creating a slight delay before impulses reaches the ventricles. So one role of the AV node, it delays the electrical impulses from the SA node going to the ventricles. Okay, so there is a slight delay. Actually, this one gives, because once the SA node and internodal pathways, okay, the electrical impulses reaches the atrium will contract. Okay, so the impulse will go directly to AV node, and before the AV node release the impulse going to the bundle of His, the, the atrium contracts first. So there's a delay. So after that, okay, one important thing is the intrinsic rate of the AV node, 40 to 60 beats per minute. Actually, if your SA node stops and does not function, you will not you will not die, because you have the secondary pacemaker, which is the AV node, and it emits impulses 46 to 60 beats per minute. Your heart rate will slow down. That's why they, some person have mechanical pacemaker. Okay, and then after that, it will go to the bundle of His, which transmit impulses to bundle branches located below the AV node, and then left bundle branches, right bundle branch, and Purkinje system. Okay, look at the Purkinje system, the intrinsic uh, rate is 20 to 40. Okay, remember this three, ah. SA node 60 to 100, AV node 40 to 60, and this one will be 20 to 40. Okay, 20 to 40. Clear. Okay, so if we look at this illustration, okay, so this is the ASA node. As we said, it's located at the right part of the right atrium, and the internodal pathways, this one until the other side or the left atrium, and it goes directly to AV node, and then there will be a delay going to the bundle of His. So the delay is caused by the contraction of the atrium. When the atrium contracts, there's a delay, and then it will go to the bundle of His and to the right and left bundle branches and go to the Purkinje fiber. Okay?